let's look at our first example here and determine what makes terms like terms. Well, in order to be like terms, what you have to be is have the variable portion of the term exactly the same. In this expression, we have x squared plus y squared plus 3x minus 7y squared. We're trying to identify the like terms. So all we have to concern ourselves with is looking at the variable portion of each term. Here's an x squared, here's an y squared. Those are not like terms. There is an x. Neither of these are like terms. But we look down at the end and we find another y squared. So this first term, y squared, and negative 7y squared are considered like terms. Again, like terms have the variable portion exactly the same. Notice in these x's we have one x to the second power, one x to the first power, so that's why those are not like terms. But these are exactly the same, so those are our like terms. Let's look at our next example. Here we're going to combine some like terms. Remember, like terms are terms in which the variable portion is exactly the same, including the exponent, so be careful. Here we have 5a, notice we have a as a variable portion, plus 7a, plus 4a. So we can be assured here that all three terms are like terms by definition. Now, in order to combine like terms, what we're going to do is just combine the numerical coefficients. Now that may sound a little scary, but all that means is the number in front of the variable is called the numerical coefficient. What we're going to do then in this particular case is to add these three numbers together. We have 5 plus 7, which is 12, plus 4, which gives us 16. And then we just keep the similar part, or the a, or the like term portion. So 5a plus 7a plus 4a is simply 16a. Let's practice with another problem. Here we're going to combine negative 8y squared minus 9y squared plus 4y squared. Again, check to make sure that we have like terms. Y squared, y squared, y squared. All three are considered like terms. Again, to combine like terms, we're going to combine the numerical coefficients. So here we have negative 8 and negative 9. Remember to add negative 8 plus negative 9, that gives us negative 17. Negative 17 and a positive 4 gives us a negative 13. So what we did again is added negative 8 plus negative 9, which is negative 17, plus positive 4 gives us negative 13. And the easy part about combining like terms is that we just carry along the variable portion, which was the same for all three terms. So these three simplify to negative 13y squared. Are you ready for our next example? Let's look at it. We're going to simplify here this long expression, 5ab minus 2ab squared minus 3a squared b plus 6ab. What we need to do is identify the like terms and combine the numerical coefficients. I have an ab up front. I have an ab squared, close but not close enough. I have an a squared b, still all three are different. And then finally down here at the end, I see another ab. So basically this first term and this fourth term are considered like terms. So these are the ones we'll combine. Remember, to combine like terms, combine numerical coefficients. So I'm going to add 5 plus 6 to give me 11. That gives me 11. And again, the like term portion is just added on. I have 11 ABs. These, notice, although very, very close, are different because I have an AB square and an A square B. You must be very, very careful when you're looking for like terms. So since those are different, they remain separate terms. So I write it as negative 2ab squared minus 3a squared B. We check to make sure we combined all like terms, which we have. So that's the final simplification of that first expression. Let's take a look at the second problem down here. It looks very different from the first one above, doesn't it? In fact, I've got some parentheses here, which reminds me of the distributive property that we learned previously. So the first step here that we're going to do is apply the distributive property to both these items, and then we'll look for like terms and collect them as we did in the previous example. Let's begin. The distributive property, remember, means to multiply 5a times 2, which gives me 10a. Now I'm going to multiply 5a times 3b, which gives me 5. Notice that's a negative 3, so it gives me a negative 15ab. I'm going to apply the distributive property again to my second set over here. Be careful here because notice the negative in front of the 4 gives the 4 a value of negative 4, so I'm going to distribute the negative 4 into my second set of parentheses. So negative 4 times positive 6a gives me negative 24a, again because I have just that one negative sign. And I'm going to multiply negative 4 times the 2ab, and again, because I just have one negative sign, that gives me a product of negative 8, and then I write the ab. Now that we've expanded this here, we're ready to collect like terms. So again, we're going to identify like terms by looking at or analyzing the variable portion of each of our terms. The first one has an a, the second one has an ab. Oh, I see another a here, so I'll say that this 10a is like terms with a 24a. So I'll add those together. 10 minus 24 is negative 14. And again, we'll just put the a there. Then I look and see I have a negative 15ab, and I also have a negative 8ab. Again, the variable portion matches perfectly, so the second term and the fourth term are considered like terms. Again, don't forget, once you identify like terms, just combine numerical coefficients. So negative 15 and negative 8 give me negative 23. And then again, I just put on the like term portion of AB. So notice after I distribute and collect like terms, I get here as my final answer, negative 14a minus 23ab. Let's look at our next example. Here we're going to simplify this long expression. Remember, we're keeping our eye out for like terms. Like terms, remember, are those that have the variable portion that's exactly the same. We have 1/7 a to the second minus 5/12 b plus 2a squared minus 1/3 b. This is a little more easy for us to identify the like terms because the variable portions aren't very complicated looking. So the first one, we have an a squared. Let's look for another a squared. Not here. We have one here. So let's go ahead and underline the first one and the third one, and those are our like terms. Don't forget to combine like terms. We're going to combine our numerical coefficients. So in this case, we're going to add together 1/7 and 2. Well, that's easy. 1/7 and 2, 2 and 1/7. So let's write that down. 2 and 1/7 a squared. Now let's check our other two terms. I've got negative 5/12 b and negative 1/3 b. These are like terms. So what we're going to have to do is add together the negative 5/12 and the negative 1/3. But remember, in order to add fractions, we must have a common denominator. In this case, I hope you recognize that between 12 and 3, the common denominator is 12 because 3 is a factor of 12. So we're going to write this as negative 5/12. Notice the first fraction does not have to change. And the second fraction, we're going to rewrite the 1/3, the negative 1/3, with a denominator of 12, so then we'll have common denominators here, and then we can add them together. So don't forget to convert negative 1/3 to twelfths. We have to analyze the denominator. 3 times what number is 12? 3 times 4 is 12. So 1 times 4 is 4. So the fraction 1/3 becomes a fraction 4/12. And we put the b there. Now that we have common denominators, it's going to be easier for us to combine these numerical coefficients. So again, we'll rewrite this 2 1/7 a squared. Now notice here, we're going to add real numbers. They're both negative. So when the numbers are negative, we just add the numbers and take their sign. Negative 5/12 and negative 4/12. Add the numerators, negative 4 and negative 5, give me negative 9 over 12. And then take the variable portion, which is b. Now do you see one last step and to simplify this? We can reduce this fraction 9/12. 9 and 12, remember, have a common factor of 3. 3 goes into 9 3 times. 3 goes into 12 4 times. So the fraction 9/12 reduces to 3/4. So our final answer is 2 1/7 is 3/4 b. So notice we worked really hard on this problem. We started up here. We combined like terms. We had to convert a little bit of a fraction here to get our common denominator, combine those numerical coefficients, and finally reduced the fraction.